So hello everyone. So far we have learned what is prototyping, traditional versus rapid prototyping, what is time compression, and then usage of RP parts. And today we are going to learn about something very important. How does a 3D printing object actually get created? Suppose I wanted to print a mobile stand using 3D printer. Can I simply throw plastic into the machine and finish the product? No. So many steps happen before printing starts. Okay, so today we will learn the complete journey from idea of to an physical object. Okay, so this journey is called generic RP process. So today we are going to travel through the complete manufacturing process. We will start with an idea, then create the CAD model, then convert it into STL format. Okay. Then checks for errors, slice into layers, configure the machine, print the part, remove the part, perform post processing, and then finally obtain the final product. So think of today's lecture as following the production of birth to completion. So let me start with a simple question. Suppose your mother asks you to prepare biryani. Can you directly start eating? No, right? What do you first do? So you find a recipe, collect all the ingredients that are required for biryani, and then you cook, then you serve, then you eat. Okay. So every activity follows a sequence of steps, right? So similarly, 3D printing also follows sequence. So first I'm having an idea, then I will go to CAD software and I will design a CAD design, and then I will convert it into STL file. So and then I will start slicing, then I will start printing, and then I will start go for post processing, and then I will finish the product. So this complete sequence is called generic rapid prototyping process. Okay, that I have been given here. Okay, so can a house be built without a plan? No, right? So exactly similarly, a 3D printing printed object cannot be created without the following steps. So the generic RP process is the sequence of steps used to convert a CAD model into a physical object by using rapid prototyping technology. But don't memorize this definition, understand it. Think of Google Maps. Okay, you have a starting point and a destination. So the starting point is an idea and the destination is physical product. So the generic process is simply the route connecting these 2 points. So let us travel through each step one by one. So everything begins with the design. Suppose I want to create a mobile stand or a coffee mug or a drone component or a car part, let us say. The first step is creating the digital model. So this is done using CAD software. Some popular softwares that are there in the market, one is AutoCAD, another one is Fusion 360, SolidWorks, CATIA, Creo. So these are nothing but the softwares that we can create our design into a virtual model. So think about software development. Before coding an application, what do CSE students do? So instead they create a database design, UML diagrams, UI screens. So similarly, manufacturing engineers create CAD models before printing itself. So the output of this stage is complete 3D digital model. Okay. So can a building be constructed without blueprint? No, right? So CAD is the blueprint for 3D printing. So now we have a CAD model. The first step is finished, but there is a problem. So the printer cannot understand the CAD files directly. So the printer speaks a different language. So that language is called STL. STL stands for stereolithography. Okay. Okay. So now let me explain what is STL in very simple way. Imagine a football. Okay. So what is football made of? Many small pieces stitched together. Similarly, STL converts a 3D model into thousands of tiny triangles in this manner. Tiny triangles. Okay. So these triangles together represent the entire object. Okay. So the process becomes like CAD model initially we have created, then thousands of tiny triangles, and with that is nothing but that we call it as STL file. So STL file acts as a translator between CAD software and the printer. Now we have an STL file with us, but sometimes STL files contain error. So let us understand with the example. Suppose you download a PDF, let us say. So when you open it, you discover that some pages are missing. So the file exists, but it is incomplete. So the same thing happens with STL files also. Common errors include like holes, missing surfaces, overlapping triangles, open boundaries. Okay. If we print an incorrect STL file, the final object may be defective. Sorry. So therefore, software checks and repairs these errors before printing itself. So think of it like proofreading a report before submission. Would you submit assignment without checking you for mistakes? No, right? So exactly, STL repair is a proofreading for 3D printing. Now we are moving on to the fourth major step, slicing. So this is one of the most important step. The STL model is now converted into thousands of thin layers. Okay. This process is called slicing. So imagine a loaf of bread. Sorry. So if you cut it, let us say, what do you get? Slices, right? If you cut the bread, you will be getting the slices. So similarly, a 3D model is divided into layers. Okay. Now let me give a better example. Think about a movie. When we watch a movie, it appears continuous, right? But actually it consists of thousands of individual frames. Movies is equal to frames, whereas 3D print is equal to layers. So the printer cannot print the whole object at once. So what it will do, it will take, for example, there are 1,000 triangles. It will take 100 triangles one time, 100 triangles one time, 100 triangles one time. Okay, from STL file. So which means 100 till 10,000 or 1,000. It prints one layer at a time. So the slicing software creates instructions for each layer. So students often ask, why do we slice the model? Because printers work layer by layer. Imagine asking someone to build a 20-floor building. Would they construct all 20 floor at once? No, right? So they build floor 1 first, then floor 2, then floor 3. Similarly, the printer also prints layer 1, layer 2, layer 3 and so on. So this is called slicing. So let me explain slicing one more time because it is extremely important. Think of a video. A video is actually a collection of thousands of images displayed rapidly. So similarly, a 3D printed object is actually a collection of thousands of printer layers. So movies become smooth because frames combined. Okay, one after another, layer by layer, it is combined. So 3D object becomes complete because layers combine. So this is the easiest way to understand slicing. Now machine setup. Now we are ready to print. But before printing starts, we must configure the machine. The machine operator selects material, layer thickness, temperature, printing speed, orientation. Okay. So think about cooking. Before preparing food, what do we select first? First we select ingredients, then cooking temperature, then cooking duration. So similarly, the printer also needs proper settings. Okay, if temperature is wrong while cooking, what happens, students? You will be saying food gets spoiled. Exactly, if wrong printer settings can also spoil the print. Now the actual printing begins. This is where students get excited. Okay, the printer starts creating the object layer by layer. Okay, like layer after layer 1 printed, then layer 2 after layer, then layer 3, then layer 4. So until the object is completed, depending on the technology, material may be deposited, melted, curved or sintered. Okay, depending on the object that we require. Okay, some require melting of plastic, some require curd and some require sintered. Okay, so but the principle remains same, build layer after layer. Now after printing is completed, the object is attached to the build for platform. Sorry. Now we carefully remove it. This may sound simple, but it is important step. So think of about baking a cake. After baking cake, what we do, remove the cake from baking tray, and exactly the same idea. Print after completing the print, we remove the printed part from the machine. Now the most important step, the final step. So most printed objects require post processing. Why? Because the object may not look perfect immediately. Some common operations are required. One is support removal, sanding, painting, polishing, heat treatment. Okay, let me give an example. After constructing a house, it immediately ready. Is it immediately ready? No, right? So painting is required, decoration is required, finishing is required. All happens later after the construction of the house. So post processing is the finishing stage of 3D printing. So finally the product is ready. The finished product can now be used for testing, assembly, demonstration, manufacturing. So let us summarize the complete journey. First, what we have done, SolidWorks design, and we are converted into STL file, and then we have checked the errors in STL file. Then we sliced, then we have gone through machine setup, and then what we have done, we have printed, we are going for printing, which type of material is required. Then we remove the unwanted things. Then post process means we added some decoration. Lastly, the output. Okay, so this will be the complete diagram for generic RP process. Okay, so advantages, if you look the advantages here, faster product development, less material waste, easy design modification, and better product visualization, lower prototype cost, and also reduce time to market. So that are the 6 major advantages of generic RP process. So I can say simply faster development plus lower cost plus better quality is nothing but we call it as generic RP process. So thank you guys. If you're having any doubt, let me know in the comment section. Feel free to ask the questions. I will be answering you at any time.